Hi guys, we are going to do lesson 7, synthetic division. But before we do synthetic, we're going to go back and do one more problem of long division. So if you were still kind of stuck on how to do the long division, we're going to do a little practice on that one right now. Okay, so you're in your lesson 7 notes. The opening exercise here is find the quotient using long division. So we are going to set it up like I showed you. This one has no placeholder, so there's a cubed, a squared, a 1, and then a constant. We don't need any placeholders for this one. Okay, so there's our setup. I don't like this line. I need to do that. Okay. You know what? I apologize. Let me move it up here because I know already that I write so big that let me do it here so that I have plenty of room. Sorry about that, guys. And I'm not restarting this video. Okay, so we start with, like I keep saying, the first term of each one, right? And we look to see, basically, what would I have to multiply by x to get x cubed? And that would be x to the second. And then I take x to the second and I distribute it, right, to the x minus 1. So I'm going to multiply x squared times x, which would be x cubed. And again, they should always match. X squared times negative 1, which is negative x squared. And then we're going to put that parenthesis around it and distribute the negative. Now, my little trick I had said to you guys before was to kind of do like a sideways slash so that you know that you distributed it. Like you can look back at your notes and go, okay, it was a negative. Like this was a negative, that x squared, and then it became a positive because I kind of did that sideways slash. It's a trick. You don't have to use it. So then you take the x cubed minus the x cubed. They go away. They cancel out. I've got negative 3 plus 1 is negative 2x squared. And then I'm going to bring down the negative 6x, and I'm going to do it all over again. And again, I'm going to look at that x and that negative 2x to the second. I ignore everything else when I do this next step. And I say, what can I multiply x by to get negative 2x squared? And that would be negative 2x. And I'm going to distribute that to the x minus 1. So I get negative 2x squared. Negative 2x times negative 1 is positive 2x. And I'm going to set a negative outside a set of parentheses, and I'm going to distribute that negative through. These two should cancel out. Negative 6 and negative 2x, just combine them. That's all you got to do. It's negative 8x, and then I'm going to bring that positive 8 down. And I'm going to do this one more time. I'm going to look at the x and the negative 8x. I'm going to say, what would I multiply by x to get negative 8x? And that would be negative 8. And I'm going to distribute. Negative 8 times x, negative 8 times negative 1 is positive 8. And look at that. They match so that when I go to add them up, combine like terms, I see that I get a 0, which means it has a remainder of 0. So here's the question. Okay, now go back to the problem. This x minus 1, right, that is what we did the division with. It says, is x minus 1 a factor of that problem, that polynomial x cubed minus 3x squared minus 6x plus 8? And we're going to say yes. X minus 1 is a factor because when divided, the remainder is 0. Okay? So let's take a look at that, that as a graph. So let's take a look at that polynomial. Same problem. The x cubed minus 3x squared minus 6x plus 8. Let's look at it on a graph of like a y equals as a function. Okay, now if you look at it right here, what do you notice is occurring at when x equals 1? So look at that. When x equals 1, it is what? We call that an x-intercept, right? That is an x-intercept. Also called a zero. All right, so we know it's a factor. Like if I were to look at it on a graph, I know it's a factor because it's an x-intercept. Okay, I'm going to show you the other two factors. Even though we didn't do division, I can see two more factors. When x equals -2 and 1, 2, 3, when x equals 4, those are all factors of that polynomial. Okay, so now the interesting piece though is that remember, or I'm sorry, they're all x-intercepts. Let me rephrase it. They're all x-intercepts. So the factors, when I had x minus 1, this was the factor, but x equals 1 is the x-intercept or the zero, or also we call it a root. We call it a root, okay? So I want you to go back for just a second. I'm going to move it to the side because I really think this is a powerful explanation too. I'll give you a real simple one. X squared minus 4. Y equals x squared minus 4. When I set that equal to 0 and I factor it, right? Okay, so if I set this y equal to 0 and I factor it, it's a difference of perfect squares, and I solve, look at this. X equals 2, and then this is going to be when I set it equal to 0, x equals -2. We did this, I know you did it for sure in algebra when we did quadratics, and I think you might have entertained it a little bit in geometry. So you can see that this is the factor, like x minus 2 is the factor, so x equals 2 is the root. Okay, so you remember those, you have to set it equal to 0 and then you solve, and it's the opposite, is the opposite sign. So the same theory is coming here. I had x minus 1, oops, and I wrote it already. I had x minus 1 is the factor, x equals 1 is the root, okay? And that's how it comes about. All right, so it says determine the remaining zeros and use them to find the other factors. Well, we just did that. We found those remaining zeros. X equals -2 is a 0. X equals 4 is a 0. So I'm going to put 0 here, right? And then the factor of that is that opposite. So the x plus 2 is the factor. X minus 4 is the factor for that one. Okay, does that make sense? Hopefully it's coming back. We'll have other opportunities to be able to see it. Trust me. I've got some more for you coming up. Okay, so it says this is known as a factor theorem, meaning if we know that c is a root or a 0 of a polynomial, then x minus c is a factor of the polynomial. Conversely, if x minus c is a factor, then x equals c is the 0 or the root, okay? So we know then when we do that division, we know that it actually has a remainder of 0. That's how we are determining it. You're doing a long division. So we will use this idea to learn a quicker way to divide polynomials if the divisor is x minus c or x plus c. Okay, it's called synthetic division. Now, there's some explanation on here, like this is like written out, this box is written out for you to kind of go through it and read it later. I'm not going to read it to you right now. We're going to do synthetic division though, up here. We're going to come back up here and I'm going to explain that box down below, all right, in my own words. Okay, so synthetic division is this. You take the factor, the potential factor, x minus 1, and you find the root of it. And you say the root is x equals 1, okay? And then you set this synthetic division up like this. I call this a shelf. So the root 1 goes on the shelf, okay? And then what you're going to do is you're going to take the coefficient of each of these. Let me do it in red. Okay, so you're going to take the coefficient. So this is 1. This is -3, -6, and 8. And you're going to ignore the variables. You're going to just take, for that dividend, you're going to take just the coefficients. You're going to take 1, -3, -6, and 8. Okay, see where I got those? 1, -3, -6, and 8. Okay, and I'm going to put them right there. And then this actually, and I didn't say this, synthetic is actually like a shortcut to long division, because long division obviously is long. So this synthetic division is a faster way to determine what the remainder is and to actually do the whole process, okay? And we're going to do it on the back. We're going to do it like a couple times, like 3 times for sure. All right, so I have it set up. I bring the first number down always. I bring it down and I put 1 there, okay? And then I take this value and I multiply it by what's on the shelf. So 1 times 1 is 1, and I put it there. And then I just combine like terms, which is these values, right? The constants here, and they're constants now. So -3 and 1 is -2, okay? Then I do it again. I take the -2 and I take the factor, what's on the shelf, and I multiply them. -2 times 1 is -2, okay? And I have -6 and -2, I combine them, and I get -8. And then I take that -8 and I multiply it with what's on the shelf again. So -8 and 1 is -8, okay? And then 8 and -8 is 0. So guess what? This is my remainder. All right, that's my remainder. Now, if you look, there's a similarity here, right? So this 1, -2, and -8, look at it, it's up here. 1, -2, and -8. See it? So what you do is you go down one exponent from what the original problem was. So the degree, in this case, was x to the third, right? The highest exponent is called the degree. We go down 1 from there. So we do x to the second. This is x to the second. Minus 2x minus 8 is what the result is. So this is the quotient, the result of the division, which is the same thing as that. A little bit easier than long division, right? All right, let's go to the back page. Oh, shoot, I got to change this picture again. Look at this guy. Next page. Oh dear, we don't want my face either. I've pretty much done this almost every video on you guys, haven't I? Oh dear, you definitely don't want that bigger. Oh my God. Come on. Small, Mrs. Reese. Oh, much better. There we go. Okay. Determine the quotient using synthetic division. Okay, here we go. We're going to do it again. Much faster method now. Ready? You're going to take, this is the potential factor, x minus 8, right? You're going to find the root of that. Remember that x minus 8, if I were to set it equal to 0 and I solve, this is the root, okay? I'm going to put it on the shelf. Then I'm going to take the coefficients to that dividend. So I've got 1, a 4, and a 10. I've got 1, a 4, and a 10. Okay? And I'm going to start with bringing the first number down, 1. And then I'm going to multiply that 1 by what's on the shelf. So 8 times 1 is 8. And then I'm going to add 4 and 8 is 12. And then I'm going to take 8 times 12 and multiply them. and I get 96. And then I'm going to take that 96 and 10 and add them, and I get 106. So that tells me right there, and I'm done, this is the remainder, remember. So I know right now that x minus 8, when I come back up here, x minus 8 is not a factor because it has a remainder. So we're going to set it up. Okay, remember the highest exponent was 2. So this becomes, so not instead of x to the second, this becomes x plus 12, right? So it goes x to a constant with a remainder of 106. And remember how we did this yesterday? We put it over x minus 8. So this becomes my answer. Okay? All right. Oh my goodness, look at this one. So number 2, I've got x plus 1 is my factor. So negative 1 comes on the shelf. And then I've got x to the 4th, which is, it has a coefficient of 1. X to the 3rd has a coefficient of negative 2. X to the 2nd has a coefficient of negative 19. X has a 32. And then we have a constant of 48. And we're going to run through it. Now, could you imagine doing that one long division? That would be long. That's why they call it long division. Okay? This is much faster. I'm going to bring the 1 down. Okay? And you take the 1 times the negative 1, multiply them. All right? Put it there. And then negative 2 and negative 1, I'm just going to combine. And then I'm going to take negative 3 times the shelf, negative 1, negative 3 and negative 1, multiply to be 3. Put it there. Combine. Negative 19 and 3 is negative 16. Negative 16 times the shelf times negative 1 is 16. 32 and 16 is 48. Okay? 48 times the shelf, negative 1 is negative 48. And ooh, I can see it already. Look at that. They're going to combine to be 0. Whew. Remainder is 0. That means that x plus 1 is a factor. So again, if I were to graph that, right, if I were to graph this as a function up here, then x equals 1 will be an x-intercept. Okay? So let's set it up. Okay, this is x to the 4th, 4 was the degree. So I'm going to go x to the 3rd minus 3x to the 2nd minus 16x plus 48 is my result. What do you think of that? Pretty good? Okay. Now let's do one where we have placeholders, because you remember the placeholders? So the last 2 we did, take a look. We had a squared, like for 1 we had a squared, an x, and a constant. And then for 2 we had a x to the 4th, x to the 3rd, x to the 2nd, x, and 48. It was going in descending order and we didn't skip any, but look at this guy here. So right here I got x to the 5th, I'm missing x to the 4th, and I'm missing x to the 2nd. So we're going to put placeholders just like we have before. Okay? So on the shelf goes negative 1 because the root is x plus 1. I'm going to start with x to the 5th. I'm going to put a 2. X to the 4th is gone. I'm going to put a 0. X to the 3rd has a power or has a coefficient of 1. We're missing x to the 2nd, right? And we're missing x to just x. And then we have a negative 2. So to kind of go through this again, let me say this. This is x to the 5th. This represents x to the 4th. This represents x to the 3rd. This represents x to the 2nd. This represents x to the 1st. And then this is your constant. Okay, so you got to have all of them there, right? Okay, so I'm going to bring this 2 down. I'm going to multiply the 2 times what's on the shelf, which is negative 1 again, which is negative 2. 0 and negative 2 combined is negative 2. Negative 2 times negative 1, 2. 1 and 2 add to be 3. 3 times negative 1 is negative 3. 0 and negative 3 combined to be negative 3. Negative 3 times negative 1 is 3. 0 and 3 is 3. 3 and negative 1 is negative 3. And I have a remainder of negative 5. Okay? So when I go to write this now, I go one less than the degree. Remember, the degree is that highest exponent. I'm going to keep saying that is 5. I'm going to go one less than that. So this comes down to 2x to the 4th minus 2x to the 3rd plus 3x to the 2nd minus 3x plus 3 minus 5 over, remember we had to put it over what the dividend was, x plus 1. And there it is. What do you think? Got it? Okay. I'm going to do one of these, and I'm going to leave 6 and 7. I know I've left 7 in the other one, but I want to do that when we get back in class the next time I see you. Okay, so for k, it says find k so that x plus 2 is a factor. Okay, now notice k is your constant here. So we're going to set it up, sugar. We're going to set it up just like we normally do, as if we are doing synthetic. And we've got a 1, so there's my shelf, 1, 5, 7, and then I've got k. Now, this is what you got to remember. For it to be a factor, I want this to be 0 in the end, right? So run through it, and then when you get here, then we'll do some math. We'll do some different math. Ready? Okay, so I'm going to bring 1 down. 1 times negative 2 is negative 2. So I got 5 minus 2 is 3. 3 times negative 2 is negative 6. 7 minus 6 is 1. 2 times negative 2 is negative 2. Okay, I'm going to stop there. Now I want k to be a value so that I get a 0 here because they're telling me that they want x plus 2 to be a factor. So just do the math here. X minus 2 has got to equal 0. So k has got to be the number 2, right? If it was 2, then that would be a factor. And there's my answer, okay? Something a little different for using synthetic division. Okay, guys, so hopefully that helps. Hopefully that helped with your long division, doing that first problem, because again, I know that's like a pretty lengthy process, and it's not necessarily difficult, but there are some ways that like you could easily make mistakes. So watch the video, make sure that watch this whole thing. Hopefully you have watched the whole thing, and make sure that you get to the homework. Okay? Any questions, you know where to get me. Talk to you soon.